this podcast, we're going to talk about drawing Lewis dot structures for compounds. There's a list of rules here right on the screen, and these you'll want to memorize. But once you've done this a number of times, which you're going to have to do in class anyways, they're going to make complete sense to you. So the first thing is simply we're going to count the number of valence electrons available from elements in the molecule. So as we go across the periodic table, when we find carbon, it's in group 14, which means it has 4 valence electrons. So I'm going to put 4 up here. And then hydrogen, it's in group 1, so it has 1 valence electron, but there's 4 of them. So we really have plus 4 times 1. So we have a total of 8 dots. The next thing, write the central atom first, and then place the other atoms around it. So I will always have the central atom underlined on any quiz, test, or homework. So simply you're going to write the central atom in the middle, and then we can put H's on the 4 different sides. So H there, H there, H there, and H there. Alright, the next thing is insert 2 dots between the central atom and the outer atoms to represent a bond. So I'm going to put 2 dots, 2 dots, 2 dots, and 2 dots. Number 4, place 8 electrons around the outer atoms if needed. Alright, so our really only exception is hydrogen is good with 2 because it's in the first energy level, so it only is 1s2, so it can only fit 2 electrons. It does not want it doesn't support the octet rule because it's in the first energy level. So in this case, place 8 electrons around the outer ones unless it's hydrogen, so we're done. Finally, count the dots and compare to your answer to number 1. So if we count these dots, we have 2, 4, 6, 8. We're going to compare it to number 8. If equal, and each atom has 8 electrons, you are done. Alright, so this is the electron configuration for CH4. The next thing we're going to do is SO2. So S, we see, has 6 electrons, plus 2 times 6, so we have a total of 18 electrons. Again, I'm going to put S in the middle, and then I'm going to put O's on just 2 sides now, because I only have 2 O's to put around there. And then we're going to put 2 dots between. And that takes us right to number 4 again. Place 8 electrons around the outer atoms if needed. So O's do want 8. So everybody wants 8 except for hydrogen. Alright, now we're going to count our dots. Let's see, count dots and compare. So we've used 2, 4, 6, 8, 10, 12, 14, 16. But we have 18 dots we can use. So if we go back, if too many, place remaining dots around central atoms. So we have 18 to put, but we've only put 16 around. So we're going to put 2 here. And then the next thing is, are they equal, and does everybody have 8? And the answer is still no. So if there's not enough, we're going to rearrange our electrons around our outer atoms in order to form double or triple bonds. So simply what that means is we've used 18 dots, but this oxygen on the right has 8 dots around it. This oxygen, I'll just draw circles, has 8, but this S in the middle only has 6. So what we're going to do is we can move dots. So I'm going to, just with some red ink, I'm going to cross out these at the bottom, and I'm going to put them right here. So now everything you've Venn diagrammed, we still have 18 dots because I erased the ones on the bottom, and I just moved them so that O and S are not sharing 2 electrons, but they're now sharing 4 electrons. So now everybody has 8. We've used 18 dots, and this is what SO2 would look like. Our last one then is SiO2. Silicon has 4 plus 2 times 6. So that's 12, so we have 16 dots. So we're going to put Si here with an oxygen and an oxygen. 2 dots between, show a bond. You're going to be outside 8 that wants 8. So again, if we look at this, oxygen has 8, oxygen has 8, and our silicon currently has 4 dots around it. If we count our dots, 2, 4, 6, 8, 10, 12, 14, 16, and that's an I right there, just so we're all on the same page. So we've used 16 dots, and we have 16 dots, so we can't add any more. So this time, Again, we're going to kind of double up, and what we can do is we can cross out these and put them between. And then the next thing we could do, we could either cross out these on the bottom and make 6 showing on this side, or you could cross out 2 on this side and make it kind of 4 and 4. So either way is equally good. But right now, we're kind of going to draw it like that. So that is how you draw Lewis dot structures for compounds.